Hello everyone, this is Ganesh. I'm an engineer at Harmony. In this video, I'm going to talk about our Ethereum to Harmony bridge. Let me present my slides. Okay. The outline is as follows. I'm going to quickly give an overview of Ethereum to Harmony bridge, and I'm going to talk about the bridge SDKs and other useful resources for our developers. I'm also going to show you a quick demo on how to build using the bridge SDK. And finally, I'm going to also talk about our trustless version of Ethereum to Harmony bridge. So Ethereum to Harmony bridge, we call it Horizon. It's a two-way bridge using which you can transfer assets from Ethereum to Harmony and also the other way around from Harmony to Ethereum. The assets that you can transfer are like stable coins like a BUSD, link tokens, or any ERC20 asset. Typically, it costs end user around $3 for Ethereum to Harmony flow, where the user is going to sign two Ethereum transactions. And in the Harmony to Ethereum flow, it's going to cost nothing for the user because the bridge is going to bear the cost. In terms of time, for Ethereum to Harmony, it's going to take about 5 minutes. Which includes time to perform two Ethereum transactions and around 13 block wait time for making sure that the transactions are reached to finality. And for the Harmony to Ethereum flow, it's going to be much lesser. Here is a high-level overview picture of Ethereum to Harmony flow, where the end user is going to submit a request to transfer their assets from Ethereum to Harmony to the bridge. When they submit the request, they are going to sign two transactions. One is approve to transfer user's token from user's account to the smart contract. And also another transaction is to perform the lock or transfer the token from user to a smart contract on Ethereum side. So bridges hosts a set of trusted validators who are going to listen to who are going to perform a 13 block wait and make sure that the user's lock transaction has been finalized on the Ethereum side. And upon the finality wait, the validators are going to submit a mint request to a smart contract called Harmony Manager on the Harmony blockchain. This smart contract, after receiving enough requests from the validator, is going to mint tokens for the user. So in this way, users are going to lock up a number of tokens or asset on the Ethereum side and going to get 1:1 amount of tokens on the Harmony side. So in the other flow where user wants to burn their tokens on the Harmony and unlock the tokens that were locked on the Ethereum side, they're going to again submit the request to the bridge by signing two transactions, approve and burn. And bridge again has a set of validators that are going to listen to the burn event that was performed by the Harmony manager. And they're going to make an unlock request to the Ethereum manager. The Ethereum manager, after receiving enough requests from the validators, is going to unlock the tokens, where it's basically going to transfer the tokens that are held in the Ethereum manager back to the user. So that is the flow. In terms of resources for developers to integrate with our bridge, the bridge is actually a service that is hosted for both mainnet and testnet, available under these URLs. And Bridge SDK is made available in this particular GitHub repository, and we also provide a Bridge UI widget that can be easily integrated into any of your front-end applications. And we also provide Bridge RPCs for a developer who likes to have a fine-grained access to the bridge. So next I'm going to quickly show a demo in which I'm going to create a React web application. And I'm going to add a bridge SDK as dependency and perform Ethereum to Harmony transfer of assets. And I'm also going to show integration with the bridge UI widget. So let me go ahead and open command prompt. Here I'm going to create a sample React app called demo app. Meanwhile, let me go ahead and it will take around 1 minute or so. So let me go ahead and talk about our bridge here. You can see the bridge is hosted under bridge.harmony.1. It allows performing two flows, Ethereum to 1 and 1 to Ethereum. And in both the flows, you can use a BUSD to transfer or link or any ERC20, where you can see a list of all popular tokens are available here. And you can also input your custom ERC20 address. For using the bridge, you need to have a connection to MetaMask. And also you need to have a one wallet. You can also see the Assets Explorer, what are the particular ERC20 address are mapped to how many HRC20 address and so on, and how much value is locked. And you can also look at the Transaction Explorer for individual transactions, history of individual transactions, and so on. There's information and FAQs that you may find useful. The same bridge is also hosted on testnet under testnet bridge.harmony.io. Here you can also request some test tokens, BUSD and link. Other tabs are similar as mainnet. We also have a decentralized exchange that we plan to integrate with Bridge, which is a fork of Uniswap. So let's go back here and see. Okay. We have created a React app. So let's go ahead and demo app. Okay. So you can see here, if I do yarn start, it's going to show the application. So initially it's going to take, here it is. So this is our application. We are going to integrate our Bridge SDK into this application. So let me close that. So here is the GitHub link to our Bridge SDK. So what is here we have? So we have, this is a JavaScript or TypeScript SDK. So we just have to do npm install into the same directory. So I'm under demo app. So let me go ahead and do npm bridge SDK. So while it is installing, let's see what we can do with it. So initially you had to create a bridge SDK instance, import some types, and then also create a configuration. And when you create a bridge SDK instance, you are going to supply a log level. We have 3 types of log. You can disable the log. You can have only minimal log where you only see errors and success notifications, and a detailed log also you can see. In terms of config to this instance, you can supply mainnet and testnet configurations, where this particular configuration, what it have is that, for example, in the mainnet configuration, you can see it has links to validators and information like the contract addresses of bridge managers and things like that. So for developers, you can either start with using testnet, and later when your application is ready, you can migrate to mainnet. As I mentioned, Bridge requires a connection to the wallet on the Ethereum side, MetaMask, and the Harmony side, one wallet. Bridge provides an API where you can directly add the private key. If you are developing a command line application, you can directly call this function and use the private key that is from the environment or any other place. Or if you're developing a front-end based application, you can directly call this API called set use MetaMask that is going to pull the account information from the MetaMask. Similarly, you can use one wallet and also Math wallet. And then after you set up the wallet, and next step is to perform the transfer. Here in this case, you can see I'm going to transfer Ethereum to Harmony BUSD tokens and specify the amount and specify my Harmony address and also Ethereum address. And you can also, after you perform the operation, you can also get the information about the operation by using the get operation API. So let's see if we have, okay, we have installed Bridge SDK. So let's go ahead and open application and editor. Okay. So here we have to, this is a JavaScript React application. So we have to modify app.js if you want to invoke the bridge functionality. So let's see. Okay, let's copy paste this. I'm going to simply create one, I think function. You can do it any way that you want. This is one of the way I'm going to do is blah, blah, blah. And then this is just a init code. And then I need to, for my application, I'm going to pick the MetaMask and one wallet. So I'm not going to supply the private key, but instead let the application pick it from the plugins that I have. And then finally, I'm going to do this operation. Okay, small mistake here. Let's do operation. Okay. Let me transfer 10 BUSD tokens. And I need my one address and ETH address. So for ETH address, I'm going to, since we are going to perform this on testnet, as you can see, I use the config of the testnet. I have MetaMask connected to Co1 testnet. So I'm going to copy my account one address. Go ahead and paste on the Ethereum address. And I'm also going to connect to my one wallet here. Make sure testnet and it's connected. Okay, test account. So I'm going to paste the test account here. And I'm going to do the 10 tokens transfer. So after the operation is done, let's also try to do the get operation using the operation ID and just print the operation to the console. So okay. So let me format this code. So that's all I'm going to do. So when I load up my application again, it's going to execute this code where it's going to read my account information from the wallets and then perform using the SDK, perform an Ethereum to Harmony transfer of BUSD tokens. Amount is 10 from Ethereum address to this particular Harmony address. And I'm going to just look at the operation. Okay, so let's go ahead and run. Okay, for running, just do yarn start. So that should do it. Initially, it will take some time to build the application. And meanwhile, we can also go ahead and open our developer tools so that we can have a visualization about. We can look at the console. It should load the application. Let's give it a few seconds. Okay, so we have our application. So you can see It's already popped my MetaMask to sign transaction. As I mentioned, when you transfer from Ethereum to Harmony, you need to sign 2 transactions. So let me confirm my first transaction. You can see, okay. Okay, it asks for the second transaction here. So let's go ahead and confirm that as well. So yeah, one thing to mention is that I selected no log, log level 0. So if you select log level 2, you will see all the console output here. So what is the other way? Since I already missed that opportunity, let's go ahead and open our testnet bridge and go to the transaction. And you can see that there is an in progress transfer that is happening from this account to this account. So these are the accounts that I used here. You can see that approve lock and lock token are the 2 transactions that are signed. They are succeeded, and currently I'm in the stage of waiting for finality. It's going to be 13 block time. In Cohen testnet is around 4 seconds per block. So it should finish soon. So yeah, wait for finality, succeeded, and mint tokens will succeed in just about 5-6 seconds or so. So yeah, just give it a few more seconds for this one to update. Okay, succeeded. So here, let me just stop this one and go back here. Stop and go ahead and change this to log level 2, just for the sake of we want to see the output. So let me start this again. Let's open the app. And let's go ahead and go to the developer console. Okay, now you see all the logs here. So again, confirm 2 transactions. You can see the balance before the transfer and all the other information. This is quite helpful when you want to debug the bridge. So you can see that I did approve and I did the lock token transaction. So you can see that both have succeeded and currently waiting waiting for finality. So that's going to take a little bit of time. So let's go ahead and check here in the testnet explorer. We also see that we are in the stage of waiting for finality. So you can see this number changing here. It should finish soon. Let's give it a few more seconds. Generally, it auto refresh few seconds, once in a few seconds. So this is still in progress. You can see here it's almost done. We should see log messages soon. Okay. So the waiting for finality is done. Now currently on the mint stage. So you can see here finality succeeded and the mint token is happening. And in any moment, mint should, okay, mint succeeded. If I go back here, you should see, okay, operation was success. And we, since in our code, we print the operation whole object, we can see that object has multiple steps like approve, lock, wait, mint token. You can scroll down and see all the status of individual steps. And each operation has a unique operation ID. So, okay, this is the thing. And the next thing I want to show is let me go ahead and stop this. You can, okay, let me go ahead and stop this. and also in the here. Next thing I want to show is the widget. So Bridge UI is also made available, like you saw in this case, right here in the Bridge. This is a UI. If a developer wants to directly integrate this as a widget, they can also do so. So for doing that, you need to npm install Bridge UI SDK and some dependent component here. So let me go ahead and install that. Uh, so what we need to do next is basically this part. This is an example here. Okay, this is installed. So let's go back to our application and let's comment out this code, comment this code, and also comment my app code. And I'm going to freshly import some Bridge UI types. And I'm also going to copy paste this app. So what this app is doing is basically going to give you the widget using which you can perform the bridge operation. So, okay, this is, since it's that was a TypeScript code. So since we are using JavaScript, let me quickly adjust by removing the type information here. Almost done. Okay, so this is good. So let's go ahead and do again and start. So, okay, this should boot up Bridge widget that is now integrated with my React application. Let's see, give it a few more seconds. Okay, so this is a widget. You can do both transfers. So let me do, I have 10 BUSDs, so let me do 5 of them. And this is automatically connected to my one wallet. So I can do one wallet and MetaMask. So I can do all the operations in the same manner. So for Ethereum to Harmony, I had to sign 2 transactions and so on. So let's wait and sign the second transaction. Okay, so it's going to proceed. So you can go ahead and check in the testnet transactions. I initiated one more for 5 BUSD transfer. So it's going to finish. So this is one UI Bridge UI widget that you can easily integrate with your front end application that you are building. So those are the 2 things. Apart from Bridge SDK that I showed here, you can find more examples inside the example directly here. You can also look for what are all the token types and so on. And we also, in this link, we also provide bridge RPGs. So if you want to have like a fine-grained bridge access, then you can use the RPGs. RPGs have like several more steps. It's a little more cumbersome than directly using the SDK. In the RPC, you first have to create an operation and specify what type of operation it is, Ethereum to Harmony or Harmony to Ethereum. Select the token type and provide the operation ID, and then select the amount. All the information are in this link if you'd like. And this is handy if you, let's say, you don't want to develop a JavaScript application. Instead, you want to develop a Go or in any other language or directly fire some curl commands. In those situations, you can use these RPC. In this case, after creating the operation, you have to perform execute smart contract functions like approve and lock token. So information about these are also available in this page. And this is kind of a very fine-grained way of integrating with the Bridge. So hopefully, most developers will use the SDK directly, which is very convenient. That's about the demo. let me go back to my slides here and quickly talk about a few more stuff. Yeah. Um, we also, in the process of releasing a Medium article and a white paper describing our Trustless Ethereum to Harmony bridge design. I look forward to this Medium article and the white paper. Uh, the previous version that I showed you is a trusted bridge where we have a set of validators that confirm the cross-chain events. Whereas in this case, you can see Ethereum to Harmony flow. A user or a client is going to perform the lock transaction on Ethereum side, and he's going to obtain the proof of lock from an Ethereum full node and use that proof of lock to perform the mint operation. So user is going to drive all the operations by himself. There won't be anything like a bridge backend that is like a black box that's going to under the hood going to perform all the bridge activities. So this is going to be more trustless, where there's no trust assumption on any of these components, and it's also more decentralized. So after the client or the user submits the mint request to Harmony blockchain, the Harmony blockchain has a smart contract, bridge smart contract, that's going to receive all the headers from Ethereum and going to fully verify the mint transaction proof of lock that user submits. Similarly, in the Harmony to Ethereum flow, user is going to submit a burn transaction and obtain the proof of burn and use that to invoke unlock transaction. In that case, we have a bridge smart contract that is running on Ethereum side, Ethereum blockchain, that is going to obtain the Harmony headers and use the block headers to verify the proof of burn. And after verification, it's going to unlock the tokens. So the flow is similar, locking and unlocking, but it's going to happen based on fully verifying the proof that is submitted by the user. So more information you can read in our white paper about our innovation and so on. So you can also contribute or plan to work on the Trustless Bridge components for your hackathon. We are going to, this is in particular, this particular GitHub repository, you can, we are going to make a full specification of various components available. If you are interested, you can also decide to work on one of these or many of these for your hackathon. So we welcome all your contributions. That's all. Thank you for attending my workshop.